Electric field vectors in an unpolarized light can be resolved into vertical and horizontal components. This is a simpler way of representing unpolarized light. Vibrations in different planes, and this is the front view of wave. Here is another view, that is a side view of the wave. The double-ended arrow represents vibrations in the plane of the paper, and dot represents the vibrations are perpendicular to the plane of the paper. This is the dot perpendicular to the plane of the paper, and this is the double-ended arrow. This is the vibrations in the plane of the paper. Here the figure calcite crystal of crystallographic AA dash. This is the calcite crystal. Its crystallographic axis is in AA dash. This is the source of light S. It is producing unpolarized light, that means its vibrations in different directions. Ordinary unpolarized light from source is allowed to pass through the crystal. After passing through the crystal, the emergent light is found to be slightly colored and less intense. On rotating the crystal about the beam axis, color will not be changed. That means no change in color of the emergent beam. The resultant emergent light from the crystal contains vibrations only in one direction, is called linearly polarized light or linearly plane polarized light. Come to the picture. Another calcite crystal having crystallographic axis BB dash parallel to AA dash is placed along the path of the emergent beam. The emergent light from the crystal A passes through the crystal B, and the light is colored. In this position, crystal A and B are said to be in parallel position. Now, the second crystal BB dash is slightly rotated. The intensity of the emergent beam from BB dash reduces, and after rotations more than the initial one, the intensity becomes 0 of the emergent beam from the BB dash. That means light is completely extinguished if BB dash is 90 degree to AA dash. On continuous rotation, that already I have told, the crystal B about the beam axis SO, the stage reaches the crystallographic axis AA dash and BB dash are perpendicular to each other, and the intensity becomes 0. That is light extinguished. The crystal A is called polarizer and B is called analyzer. Now in this figure, unpolarized light from left side is falling on the crystal and its crystallographic axis, as already I have discussed. After the polarization, the vibrations is shown in the right side. Here ABCD, it contains the plane ABCD, it contains the vibration of plane. That means vibration of plane polarized light. ABCD is known as the plane of vibration. PQRS, it has no vibration. It is just perpendicular to the plane of vibration. This is known as the plane of polarization. Thus, plane of polarization contains no vibration. Plane of vibration contains vibrations. Malus law. When a completely plane polarized light is incident on an analyzer, the intensity of emergent light varies as the square of the cosine of the angle between polarizer and analyzer. This is the unpolarized light is falling on the polarizer. This is the axis of the polarizer. This is the plane of linearly polarized light. Now after passing through the analyzer, this is the axis of the analyzer. So its angle is theta with the angle of the polarizer. So the Malus law states that the intensity becomes I is equal to I naught cos square theta, where I naught is the intensity of the incident radiation. Polarization by deflection. This phenomenon was discovered by Malus from the glass surface. He found that the polarized light is obtained when ordinary light is reflected by a plain sheet of glass. Here in our picture, incident ray is falling along this direction at an angle of I, and it is reflecting along this direction and coming to our eye, and this is refracting along this direction. So this light is polarized or partially polarized. I am discussing the conditions in later figures. This is the incident ray falling at an angle of theta. When unpolarized light is incident on the surface of a transparent medium, for example water, glass, etc., some part of light got reflected, this is reflected, and some part of light refracted through the material. At a particular angle of incidence, the reflected ray is completely plane polarized and vibrations are parallel to the surface of the glass slab. Particular angle is called Brewster's angle.